In this screencast, you'll learn about speed and velocity and how to calculate them. In physics, speed is how much distance is covered in a certain amount of time. That's the same definition you've probably seen for speed before. The symbol for speed is a lowercase s, and the units are meters per second. The equation is speed is equal to distance divided by time. And if we shorten that and use just the variables, it's S equals D divided by T. Keep in mind that speed will always be a positive value because it's based on distance, which is a scalar. A scalar is a new word, so we'll talk about that in just a moment. But keep in mind that speed is based on distance, and since, as you remember, distance is always positive, then speed must also always be positive. However, when we're dealing with speed, speed only answers the question of how fast. Speed doesn't tell us anything about the direction moved. Let's go back to the idea of vectors and scalars. So a scalar is a value for which direction is not included. Direction doesn't matter. Direction doesn't matter when we talk about mass or how much matter is in an object. So mass is a scalar. Time is a scalar because time doesn't really have a direction. Time can only move forward. So we can't talk about moving back in time unless we're in a movie or something, which isn't true. So time is a scalar. As we talked about on the last screencast, distance is a scalar as well. However, displacement is a vector because in order to know the displacement of an object, you must know the direction involved. So scalars do not require directions, but vectors require directions. So how do you calculate speed? To find speed, you need to know the distance an object has moved and how much time it has taken to move that far. So in this example, we have a football player who moves 40 meters. And let's assume that that 40 meters is shown on the screen in this windy path down here at the bottom. He covers 40 meters by moving back and forth, and weaving in and out of players. He moves 40 meters, and he does it in 8 seconds. So his overall speed during that time is 5 meters per second. Interesting. If you think about Tyreek Hill, who's the fastest player in the NFL right now, Tyreek Hill's speed at 100 yards turns out to be 9.8 meters per second. So Tyreek Hill is super fast. However, if Tyreek Hill had to run the pattern that we just saw that went back and forth and sideways, sort of like this, his speed might actually drop because he would have to slow down as he changed direction so much. All right, velocity. Velocity is the rate of change of position over time, or stated more simply, velocity is displacement divided by time. The symbol for velocity is a V, a lowercase v. Remember when in our density unit we used a V to stand for volume, and that was an uppercase V. The SI unit for velocity is meters per second, and the equation shown here shows that velocity is displacement divided by time, or if we expand displacement out to the one we saw in our last screencast, displacement is final position minus initial position divided by time. The shortened versions of those equations are shown here. Velocity is delta x over t, or its final position minus initial position, that difference divided by time. Keep in mind as well that when we find a velocity, we do know positive and negative direction. We know the direction of motion. So when velocity is positive, the object moves toward the right. Here's a car that moves toward the right with a positive velocity. When the velocity is negative, then we know the object is moving toward the left. So that shows it here with a negative 25 meters per second. Velocity answers two questions. Velocity answers the questions how fast and which way, because it's a vector. So how do we calculate velocity? If we know displacement in time, then we simply put it into the fraction and divide. So once we know displacement, in this case the displacement of this football player is 50 meters, and that displacement happens in 5 seconds. So that shows a displacement of negative 5 meters per second because we had a displacement of negative 50 meters. Negative 50 meters. So negative 50 meters divided by 10 seconds means the velocity of this player is negative 5 meters per second since he's moving toward the left. In this next example, this shows a football player where we know the starting and ending positions. So we know the initial position is 10 meters, final position is 35 meters. That happens in 25 seconds, so that's pretty slow. We use the larger form of the velocity equation where we put the difference of the positions. We put the final position of 35 first and subtract from that the initial position of 10 and put that over 25 seconds. So when we subtract 35 and 10, we get 25 meters, a positive 25 meters. And positive 25 meters divided by positive 25 seconds gives us a positive 1 meter per second toward the right. He's moving toward the right so that he has a positive velocity. So in summary, our vocabulary words were speed and velocity. Speed answers the question how fast, and it's a scalar because no direction is specified. Velocity answers the question how fast and which way. If velocity is positive, the object is moving to the right. If velocity is negative, the object is moving toward the left. Go ahead and finish the bookmarks for speed and velocity and do the practice with these concepts.